Well, I've set this copper one up at 2/3 seawater, or the salt index of most fly traps and Benatas and things of that sort of level, which is roughly about 80 times what a normal fly trap can handle in just basic copper level, before it's reduced, of course. So we have to see. I don't know if we can see the colour yet, but I did have to mix it up. But we'll probably see the blue colour against the light by tomorrow, and we'll see whether that blue then goes to like green and eventually turns into you know, our so-called CP tannins, which I think is not what we're really after. I think we're after the invisible ones, which are the equivalent but in the calcium area sort of thing. In other words, the calcium is reduced as well, but the copper is reduced, and which is what we see as the brown. But we want the invisible, clear or translucent so-called CP tannins. I think that's what the CP roots are actually going for. Oh yeah, yeah, not bad. Yeah, I'll pay that one. Yes, yes, that's definitely a nice level of reductive flammable gas coming off there. Yeah, that's it. Yes, that's what I want. That's what we want to see. Something like that. There is a little bit coming off the peat now. Have you noticed that? Took a while to get going. So there you go. Anyway, you learn something new over here, and the sphagnum has settled down a bit. It's got a bit sort of chunky and it's getting a bit green. So whether that's just a little, can get it into the sun. There we go. Oh, I'm missing it. Oh, the sun. Where's the sun today? There we go. So whether that's we're going to get a bit of redness or something, I don't know. Well, it's certainly green. There's a bit down there, but anyway, we'll see how we go. Learn something new every day. So yeah, that's not going too badly actually. So your ideas about, you know, not keeping them too wet, well, they don't seem to be right either. So it seems to be going quite well with the water level almost right up to the level there. So anyway, we'll keep an eye on that one, and oh, this one here, getting to the end of the day. So is it still got, oh yeah, it's still got bubbles. So on Friday, it's had 3 days and it's still checking out the bubbles. Has there been a bit of degradation? Oh, I wouldn't call it that much. I can still see the structure of the bloody bits of chalk. You know, they haven't totally fallen to bits. So if the idea that it's all made of calcium carbonate, well, that doesn't seem to ring true, does it? Because they should have all fallen to bits by now. And if the charcoal was turning into carbon dioxide, you think you'd see a lot of that falling to bits as well. And there's not that much really in the bottom after, you know, almost a week. You know, set it up on Monday. It's now Friday afternoon and it's still chugging out, and I reckon it will keep chugging out the reductive flammable gas. So it can't be air. It's been in there too long, which means it's not nitrogen, because, you know, almost 80% of air is 78% or something, is that? So yeah, and the water, eventually the water stops going down. So you know you've totally saturated, you've got rid of the air, so, and yet you're still getting all these bubbles coming off. And if we weren't in the bushfire season, I'd be able to show you with a match, but I would risk you know, thousands of dollars worth of fine. I've got to wait until April the 31st before I can demonstrate again. I mean, I have actually demonstrated the flammable nature of the gas early on, late last year, before the fire ban season started. But I have to wait until April the 31st before I can show you again and start to calibrate this stuff. Because I live in the most bushfire prone country on the planet, and we have rules. And if you don't live by the rules, you don't win by the rules, do you? But anyway, I'll keep an eye on that, and hopefully we'll be able to see some blue colour or blue tint in the water, because it's fairly strong. It's 2/3 seawater equivalent level, which is what Benatas and fly traps and cephalotas can even handle a little bit harder than that. About you know, halfway to 22 to the full seawater strength sort of thing. And but it's basically 80 times higher than what the CPs can normally handle in basic copper before it's been reduced. So it's good having these levels, because it tells you where you're coming from and hopefully where you're going to, and that's the power of science when it's built on firm foundations. So I think we might get a surprise with this one. Okay, over and out.